Okay, so I'll walk through how to use some of the datasets we released with this paper when no paths did go wrong, published at NeurIPS 2025. Particularly, I will show you this NORA 1.1 dataset. Of the three datasets we released, this is the most high quality one and the one we put the most effort into, and that's the one I would recommend you work with to begin with. And I'll show you the training split here, but the other splits look basically the same. Okay, so you need a very basic Python environment. Pandas is enough, and here is how you import the data. These are some functions that will help us visualize some of the stuff. And so when I uploaded the data to Hugging Face, basically some of the column valued, some of the list valued columns turned into string valued columns. So a small bit of code basically turns the strings back into lists. Okay, so let's zoom into one particular row. So one particular row of this trained data set that we got from Hugging Face gives you one problem instance. So a problem instance consists of the story graph, and these two columns describe the story graph. So the story edges column, it gives you a list of edges, the heads and tails of the edges as a list. And the edge type column tells you the type of each edge. So together these two lists give you all the edges of the story graph and hence describe to you the story graph. So let's have a look at what this looks like. So this function here, it basically looks at this particular row, the problem instance described by this particular row, and zips together these two columns, the edge type column and the story edge column. So these are all the edges of the story graph. So for instance, this edge captures the story fact that 17 is schoolmates with 0. Whereas this edge captures the story fact that 14 is the grandparent of 20. And then if you want to train a reasoning model on this problem instance, the reasoning model will get this story graph and it will also get a query edge. And the query edge is 15.5. So the reasoning model is being asked, what are all the relationships that hold between 15 and 5? And then there is this column called query label. Whoopsie. Import this. Bloody hell, man. Okay, I realize now. Sorry about that. Print. I think print should work here. Fine. Print should work here. Fine. Yep. So query label gives you the answer to this question. Query label gives you all the relationships that hold between 15 and 5. One thing we guarantee is that not all of these relationships are explicitly given as a story fact. So if you look at the story here, the only grandparent of 15.5 is given in the story graph. The other relationships between 15 and 5 are to be inferred by the reasoning model using the story graph and the world rules that are hidden. So the task of the reasoning model is to look at many of these examples, induce the set of world rules from looking at queries and query labels, and also learn how to apply the world rules to derive hidden facts in the story. And if you want to train a model, these are the only 4 columns that you need to know about. So these two which give you the story graph, this which gives you the query edge, and this is the query label. And then you can just start training and testing models. Let's take a closer look into this problem instance and try to see what some of the other columns uh, mean. So uh, this generates this takes this creates uh, this writes out this row in a very nice way into this file stories.2. So I'll open the file for you. And yeah, these four columns I already explained. And let me go into what this column means. So out of these four labels, one of the label is usually the hardest one to derive, and we usually call this the query relation. And this derivation chain tells you how this relationship between 15 and 5 is derived. So how do we derive that 15 is the maternal grandfather of 5? So as I showed you a little bit earlier, 15 is the grandparent of 5, that's given. And it's also given that 15 has no sons. And from that you can derive that 15 is the maternal grandparent of 5. Because 15 has no sons, 15 cannot really be a paternal grandparent. That's a Nora rule, by the way. That's a Nora world rule. And then there is another story fact that 15 is a male. And again, from the fact that 15 is the maternal grandparent of 5 and 15 is a male, you derive that 15 is the maternal grandfather of 5. This column gives you all the derivation of all the relationships between 15 and 5. So if you go through the query label and see all the relationships that hold between 15 and 5, this column will basically show you the all the derivations. So the first one I already showed you, right? That maternal grandparent. That's just the one we walked through a little bit earlier. And this is the derivation of the fact that 15 is the grandfather of 5. These three columns are metrics. They capture how difficult it is to solve this problem. So how difficult was it to infer these labels from the story? And there are many notions of difficulty. Derivation can be difficult for many reasons. This is sort of the heart of the paper. And these three are three metrics that are uh, capturing the difficulty of this of solving this problem instance. And yeah, I think it's a very high quality data set because not only do you have uh, labels, but you also have these derivation chains out of which you can create very nice labeled examples for models to learn on. And yeah, that's all I got for you. I hope this helps out.